All right. Do you guys remember yesterday what we ended the day talking about?
Was it the eclipse?
Yeah, Newman projections.
Yeah.
There we go. So here we're gonna quick draw a Newman projection of ethane, and I'm actually gonna draw two of them. Alright, so one of these projections is called the staggered conformation, and the other one is called eclipse. Does anyone have any ideas which one could be which?
The first one is eclipse. I mean staggered.
Staggered. Why?
And then the next one's eclipse. It's staggered because it goes every other, like the hydrogen.
And this one, it's called eclipse because if you think about it like the moon, when we have an eclipse when the moon comes over the sun, that's what's happening here, is the molecules from the first carbon are on top of the ones from the second. So what we're going to work on now is we're going to try to see the energies of being staggered and eclipsed. So the special thing with this, Savvy, can you put your phone away?
Fine.
Because do you remember what we were talking about with energy? And if you have these two hydrogens are on top of each other, they'll repel each other. So it's a higher energy state than if they were eclipsed. There's less of repulsion, so it's a lower energy. So what I would want you guys to do is in your notes, make a graph like this, something like this, and we'll have degrees and energy. So can y'all make a graph like that real quick? Good note taking.
I'm the poor kid in
Okay,
class.
you got it. It's all you.
There we go.
My family
All right.
can't afford.
So
I'll share with
for
the
the
group.
first one,
I'm too poor for paper.
we'll start with this staggered one. Now, the CH3s are bigger, so they'll create more repulsion. So since the CH3s are opposite each other, this will be the lowest energy conformation.
Teacher, she hit me.
I didn't mean it.
So we'll start that one there. Now for the rest of this, I want you guys to play with your models.
Give me some.
Shh, I'm drawing the graph.
Thanks, Zimmer. So for the rest of these, I want you guys to play with your models, and we're looking down carbons 2 and 3, and I would like you guys to rotate them around and try to create an energy diagram, what you think it would be.
I'm making something.
No, I need to put this here. No,
Oh.
you took mine.
Can you focus, please?
So are these repelling right now?
Give me my shit.
You took mine.
So if you look down the carbons 2 and 3, so
Oh.
turn it, so it's like this.
Good thing.
That's yours.
So you see
I'm looking this way.
here,
Okay.
yep, it's staggered.
Gotcha.
Yep,
And then
so
if
that'll
it's
be lower
turned
energy.
like this.
Yes, then there's repulsion between, and there's a lot of energy because these two methyl groups are lined up with each other. So these ones will create a lot of interference. So this will actually be your highest energy.
Gotcha. Okay.
So
Thank you.
what I want you to do is rotate them, and every 30 degrees, 60
So it
degrees.
gets higher in energy?
Yes.
I did something.
How's it going, Savvy?
Can we make A-bombs now?
Did I do the same?
Not today.
I
Maybe
made
another
the same
time.
thing.
Hey.
Stop taking my parts.
No, you
I'm trying to
stole mine.
create molecules or something.
Sure, it looked weird.
Dakota, how's your energy drawing going?
It's great. I'm a visual learner.
You're a very visual learner. I don't see you visualizing.
Clear that.
I can help you, Savvy.
So you want to be looking down.
He took some of my
Yup.
parts.
Three.
So
Yup.
it's okay.
I got it. highest energy achieved.
I need a cappy thingy.
A cappy thing? That's a hydrogen.
Yep. I need one of those.
Choose yours.
I don't know, you didn't pick it up.
Here, take one of mine.
Okay.
So you're looking down these two, this
Okay.
is 2 and 3, and then, so pretty much like, whenever they line up like this,
Mm-hmm.
it's a higher energy because the groups are
Oh.
closer together. And then when they're like farther apart like that, then like, see how they're like not lined up, like this one's not
Yeah.
in line with any?
Yeah. Oh,
Yeah.
okay. I get it.
Yeah. So then it's less energy.
Thank you, Kay.
You're welcome. So my graph shows that the degrees versus the energy, it
Yes.
goes up like.
I already did that.
Well, no, I want to learn.
That's not one, it's a small curve. See a slight angle. There are a lot of angles on faces.
Alright, how's it going?
I think we're not learning math right now.
Okay.
We got it.
School all
Yes, I understand now. Kay, help me. What? No.
Alright, so let's come together and see what our results were. So we're actually going to start at the highest energy one, so when they're eclipsed and the carbon, the two methyl groups are together, that's our highest energy. Now everyone rotate theirs 60 degrees. So now are we staggered or eclipsed?
Staggered.
Staggered. And is this higher or lower energy than before?
Lower.
Lower energy because the methyls are apart. So we can put that one about here. Now what happens when you rotate it another 60 degrees? Staggered or eclipsed?
Eclipse.
Eclipsed. But the carbons aren't on top of each other now. So do we think this is this higher or lower energy than the eclipsed version? Staggered version.
Higher.
Higher. But do you think it would be higher or lower energy than when
Lower.
lower? So it's somewhere in the middle.
Oh.
Now our next one,
So it's gonna go
rotate
like
another
this.
60 degrees.
I lied. It's gonna be a wave.
Rotate another 60 degrees, where are we at?
What are the options?
Staggered.
Staggered.
Staggered, and where are our methyls with respect to each other?
Are they lined up? No.
They're farther away.
They're as far away as they can get. So what energy is this?
It's lower.
It's very
than that
low.
one.
So that's gonna be down here.
Yeah.
Now, when we rotate another 60 degrees,
Are we back to where we started?
we're back to it's eclipsed.
It's eclipsed.
Where are the methyls?
It goes up again.
Yep. It goes up. So we're about here. Our next 60 degrees.
Now we have
Back down again a little bit. And finally, our last staggered one.
Super high.
Super high.
Super high.
Yep. So our line goes about like that. So where do you think you are most likely to find, what conformation do you think this butane molecule will be most likely to be found in?
the lowest.
The lowest. Yep. So can you guys draw me a Newman projection of the lowest energy benzene molecule?
Doesn't want you to have it. Oh.
Stop messing with your t-shirt.
Is that the
Is that
correct
correct?
configuration?
That looks very good. Yep.
That's wrong. That's eclipsed.
Very good work.
Stay.
Yep. That is staggered. Yep.
Do it.
Great job.
Oh, I need to listen to something.
I'm calling it 10 minutes.